Welcome to Astronomy for Everyone. My name is John Schor, and for this month, I'm going to be the host, and our guest will be Don Glaser, also from the Ford Amateur Astronomy Club. This program's topic will cover calendars, the different and kind of calendars that have existed in the past, how they've changed from the days of earliest man till today. Welcome, Don.
Thanks, John. A little bit different here.
Yes, it's very different, absolutely.
But I'm glad to be here to talk about calendars.
Very good. Well, on the topic of calendars, can you tell us what were the first calendars, first off?
Well, actually, John, the first calendar was the sky. People looked to the sky to regulate hunting cycles, agriculture. For instance, the Egyptians, they looked to the rising of the bright star Sirius. For them, that signaled the coming flooding of the Nile, which would start their year and let them know that that was on its way, because then after that, they could plant and grow the crops that would sustain their civilization.
Very good. Now, the Egyptians weren't the first calendar makers, were they?
No. We've found examples of calendars from all over the world. For example, deer antlers being notched with various marks indicating the cycles of the moon. Other various cultures used calendars. Even the ancient Greeks, before they wrote calendars, they would use the sighting of the Pleiades to help them decide when to plant and when to harvest. So it really goes back almost to the beginnings of our species.
All right. Well, talking about the calendars in particular, were there different kinds of calendars? Were they based solely on the moon?
Well, there are really three different types of calendars. We can see right up here on the screen, a calendar or lunar month is 29 and a half days. That's the time it takes the moon to go from one new phase to the next, and times 12 equals a lunar year of 354.36 days. Now, the problem is the tropical year, or the solar year, which is based on successive vernal equinoxes, is 365 and a quarter days. So these two numbers are really not integral with themselves. And so for that reason, three different types of calendar designs, written calendar designs, have come up. One is the solar, which is based on the vernal equinox to vernal equinox. The second one is the lunar, which is based on 12 synodic lunar months, which is that 29 and a half days. And then the third type is sort of a composite of the first two, and it's known as the lunar solar, which is basically a lunar design. But what they do in order to keep it in step with the seasons and the solar year is they add an extra month about every 3 years or so.
So instead of a leap day, you've got a leap month.
Pretty much. Again, you're falling about 10 to 11 days short every lunar year versus the solar year. So by the time 3 years go around, you're about 30 days off. So they'd add that extra month.
Well, very good. Where did the word calendar come from?
Well, we get it from the Romans, John, as we get so much stuff today. Word calendar comes to us because the Romans paid their bills on the calends, which would be the first of their month. And they would come into the public squares and pay their debts, and accountants had these huge books that they would write down the payments of the debts, and the book was called a calendarium. And so that's where we get the word calendar from.
All right. Now, the calendar, the name comes from Romans, but there were civilizations far earlier than the Romans that had a calendar.
Absolutely. One of the first calendars that we have came to us from the Sumerians. Now, they lived in that part of the Middle East that we know as Iraq today. And about 3000 BC, they developed a calendar of 12 lunar months. And they were really quite inventive people. For instance, they developed writing, the cuneiform writing that we find on tablets. They also developed mathematics, the 360-degree circle, and beer.
I can't fault them for that.
No,
absolutely.
you sure can't. You sure can't. But they developed this calendar about 3000 BC with 12 lunar months. And, well, they were quick to notice that those lunar years didn't keep up with the cycles of the seasons. And so they added, or intercalated is the actual term for it, a month every 3 years to keep that calendar in line with the solar year and the seasons. Now, after the Sumerians, we have the Egyptians, and they actually used a solar-based calendar, went off the sun, and they began their year at the beginning of the flooding of the Nile. As I mentioned earlier, that was signaled to them that the flood was coming by the first sighting of the rising of the bright star Sirius. Now, the Egyptians divided their calendar into 3 seasons of 4 months each, and you can see that right here on the screen. The first season was actually the inundation or the flooding, when the waters would come down from the Ethiopian highlands, deposit silt on the ground, which would replenish the soil so that they could plant. The second season was actually planting, when things would grow. And then the third season of 4 months was the harvesting, and then the low water. It would be a time of drought, and then they would just wait for that sighting of Sirius once again. Now, they had a calendar of 12 months, as you saw. They had 30 days in each month, but to keep their calendar in line, they added 5 days at the end, because obviously 12 times 30 is 360. So they had to make up those extra 5 days, which they did at the end of the year, to keep it in line with the seasons.
All right, very good. Now, along with the Egyptians, there was another civilization just east of them, the people of Israel.
Yes.
What kind of calendar did they have?
Well, the Hebrews used a lunisolar, again, as that combination. They mainly went with the lunar, but again, knowing, like the Sumerians, that didn't keep up with the seasons, they added the extra month about every 3 years. And if you look at the chart, you're wondering, well, why are there 13 months? Normally they went through 12, but they had to add that 13th month about every 3 years.
All right.
Now, the Islamic calendar that's used today, that's strictly a lunar calendar. They make no adjustments to keep it in step with the solar year. And so their calendar migrates through a solar-based calendar like we use about once every 33 years. So if you've ever noticed on a calendar that lists the religious observances of different faiths, you ever notice where the holy month of Ramadan seems to move through?
It migrates.
It migrates through, it moves through. That's why, because they're strictly a lunar-based calendar.
Now, their tradition is a new month starts when?
At the first sighting of the first thin sliver of a crescent moon. Many ancient cultures use that sign to begin their month.
You know what the record is for the earliest sighting of the crescent moon?
Somewhere close to about 24 hours, I believe.
That's still a lot of hard work trying to find it.
It is, but they did a remarkable job. Now, our present-day calendar actually comes to us from the ancient Romans. They had a 10-month calendar of 30 or 31 days, and the days of January and February were left unnamed because to them that was the time of evil spirits and ghosts, and they felt that if you called one of those evil spirits by name, you would attract its attention, and they lived in mortal fear of that. But by about 700 BC, their second king added the months of January and February to give them 12, and they had about 30 days in the month, but still, because it was lunar-based, it would fall short, and so they would also add an extra month about every 3 years or so. Now, we do have an image here showing how the Romans actually counted their months, and they used the phases of the moon. Okay, the sighting of the first crescent after new was known as the calends, or the first of the month. About 7 to 8 days later, at the first quarter, it was the nones. And then 7 to 8 days after that, it was the Ides. And of course, we all know about the Ides of March and Julius Caesar. And they kept this for quite a long time. As a matter of fact, until the days of the empire. And you can see here we have an image of a Roman calendar from the days of the Republic. You can see several months marked across there. And if you see at the top, it has a K. That stands for calends. If you count down, you can see there are 8 days there. And, well, back then they had an 8-day market cycle. But most interesting of all, you can see the days marked in red. Those were special days. and it's thought that this is where we get our term red letter day.
All right. Did the calendar go unchanged from the days of the Republic through the reign of the Empire?
Well, Julius Caesar made some great changes. He got the calendar back in order. The Ides of March was falling in May, and so the calendar was a mess. They determined that the year was 365 days, 6 hours long. They added a leap year every 4 years, and they thought they had it nailed. Unfortunately, you can see here on the graphic that the year is 365 days, 5 hours, and 49 minutes. So they were off by 11 minutes. And 11 minutes doesn't seem like much, but in the centuries ahead, it would cause big problems.
Didn't Julius rename a month?
Actually, his nephew, Augustus, had a month named for his uncle, and then he went ahead and had a month named for himself. So after that, there weren't too many changes until the 4th century, when Constantine replaced the Ides, Nones, and Calends with a 7-day week that we know today.
Well, very good. Thank you, Don. We'll pick this up after the break and continue our discussion on calendars. Welcome back to Astronomy for Everyone. I'm John Schroer, your host for this episode, and with us is Don Glaser. Don, it's nice having you here, and let's go and continue our topic on calendars. Now, after Emperor Augustus, what was the next big change in calendars?
Well, after Constantine made his few changes that we mentioned earlier, the next big change really didn't come to the 1500s.
Why so long?
Well, they were aware of the problem of the 11 minutes. The real problem lay in the fact that by the time it really came to be a problem, Western computists, which is what the people were called that would try to figure out these tables of the Easter cycles so that the faithful would know when to celebrate Easter, they lost the basics of astronomy and mathematics, and all they could do is just sit by and watch it scramble hopelessly out of shape. But by about 1500, they had come back to this knowledge. And so in 1570, a proposal was given to Pope Gregory XIII on how to fix this. Because for the church, celebrating Easter at the correct time was of the utmost importance. Now the Pope looked at this, and then in 1574, he gave it to a commission of astronomers and mathematicians who were to study it. They sent out ideas to the various universities around Europe, and here you can see a painting of the Pope's commission right here as they study the problem. Now, it took until 1580, 6 years, before all these ideas came back to the commission. The commission looked at it, put together a proposal that they gave to the Pope. The Pope approved of their plan, and then it was decided that in 1582, they would eliminate 10 days from the calendar. So what they decided was in October 5th of 1582 would be followed by October 15th. In addition, to keep it in line, they knew about the leap day, and that was fine, and they took account of that. But to keep it securely anchored, they didn't make years that weren't evenly divisible by 400, or century years, I should say, that weren't evenly divisible by 400 were not leap years. So for instance, 1600 was a leap year because it's divisible by 400, but 17, 18, and 1900 even though they were century years, were not leap years, but 2000 was a leap year.
Understood.
So they got this worked out, and of course it was accepted by all of the Catholic countries of Europe at the time.
But this is after the days of Martin Luther and the Reformation. What about the rest of Protestant Europe, or the rest of the planet for that matter? Did they take to this new calendar easily?
As they say, not so much. The Protestant countries of Europe, as you say, the Reformation was in full swing by the mid-16th century. And so the Protestant countries looked at this plan as really nothing more than a plot by Rome to try to regain papal control over the countries of Northern Europe who had broken away from Rome's control. Some of them even said this was a way for the Pope to make money that he lost in the sale of indulgences by selling new calendars. Now, not everybody had such a negative attitude. For example, Johannes Kepler, the great mathematician, who was a Protestant, thought it was a great idea. Even Queen Elizabeth I and her advisors said, this is really the way to go. This is correct. They saw the science behind it. But Elizabeth's archbishops would have nothing to do with it, her Anglican archbishops, and so they really didn't do anything with it. And it took several hundred years for these Protestant countries to really accept this. And here we have a chart that will show the dates of the various countries. You can see Denmark in 1704, and Great Britain and her colonies, of which we were one, in 1752, and you can see the rest of the countries listed there. Now, interesting thing, I bet you didn't know that George Washington's birthday was affected by this change from the old style, or the Julian calendar, to the new style, or Gregorian.
I wasn't aware of that. How so?
Well, under the old style calendar, George's birthday was February 11th, 1731. Okay? But when they switched to the new calendar, by that time, in the 1750s, they had lost another day, so they had to go 11 days rather than 10, so it made his birthday February 22nd, 1732. The reason for the change in year, under the Julian calendar, New Year's was March 25th, which was the vernal equinox. With the Gregorian, New Year's Day is January 1.
Very good. Now, there are some quirks and still some issues with our calendar. Do you care to talk about some of those?
Well, the most interesting one is Halloween. Okay, that one is the only one of the 4 Celtic cross-quarter days. Those are the days that are in between the equinoxes and the solstices. And that's the only one that we really celebrate as it has always been celebrated. The Celtic New Year began November 1st, and so they celebrated the night before. They felt that the barrier between this world and the next was very thin on that night, and people who had died in sin the year before came back to be judged. And so these people, if they had been sinful, were in animal form. And so to make them happy, the Celts would put on animal skins and tie horns on their head and dance all around. And
they also used another kind of decoration as well.
Well, they did, actually. They would walk around with candles to light their way to ward off the influence of a very evil villain. It was a villain that even the devil didn't want. And this evil villain's name was Jack. And so they would carve out potatoes and other gourds in Ireland. But when they came to America to celebrate Ica Samhain, that's how it's written in Celtic, that means the night of Samhain, which we celebrate as Halloween, these candles they would protect in these gourds, but here in America they had a bigger gourd to use, which was the pumpkin, to shield Jack's candles, and so that's how we get the term Jackolantern.
Very good. November 1st in the Christian calendar is All Hallows Day.
That's right, and that's how we get Halloween. It was originally pronounced All Hallows Eve and All Halloween, and then Halloween.
All right.
Now the last one that we have, John, is Easter and Passover. People wonder, why do those dates always change in our calendar? That's because those holidays are really based on a lunar calendar, and we talked about the problems of the lunar and the solar years before, and so you have to understand the rule for Easter. Okay, Passover is keyed in to the first full moon of spring, and Easter happened during Passover, and so it has to happen on that full moon of spring. So here's the rule. The rule for Easter is this: it's celebrated on the first Sunday after the first full moon after the vernal equinox. So if the full moon in March is on March 16th, you have to wait till the full moon in April. If the full moon in March happens on the 25th after the vernal equinox, then that following Sunday is going to be Easter, and that's why it moves around.
Now there's another day you wanted to talk about, something that starred in a movie with Bill Murray.
Oh, Groundhog Day. Groundhog Day. That goes back to the Celtic celebration of February 1st, known as Imbolc. It's tied in with the patron saint of Ireland, St. Bridget. It also ties in with the Saxon and German belief that the badgers who lived underground knew that spring was coming. And when the Germans came here, they didn't see too many badgers, but they did see a lot of groundhogs. And so that's why on February 1st in Pennsylvania, we see Punxsutawney Phil.
Well, Don, thank you very much. This has been a very informative time talking about calendars. We'll stand by for the next part of our show, which will be our term of the month with Mr. Steve Whitty. Thanks again for joining us, Don.
The term of the month for September 2011 is equinox. The term equinox comes from really two words, one meaning equal and the other meaning night. And the idea was that it's a day when day and night were of equal length. These days, however, we have a new term that means exactly that, which is equilux. Equinox itself means something slightly different. It's when the sun is straight overhead, what we call the zenith, at the equator. It's a point in time, it's not really a day. Now we have two equinoxes a year. Normally we have, or historically we have called them the autumnal equinox and the vernal equinox. The autumnal equinox, you think of it as the fall. But when it's fall in the northern hemisphere, it's spring in the southern hemisphere. So it is, since we have world audiences for shows like this, we're now trying to call it the September equinox and the March equinox. Now we have two equinoxes a year because of the Earth's tilt. So if this is the sun and this is the axis of the Earth pointing north, then half of the year, more or less, the northern hemisphere is pointing toward the sun, and on the other half of the year, the northern hemisphere is pointing away from the sun. Halfway, more or less halfway between that, we have the Earth is still at a tilt, but neither the northern hemisphere nor the southern hemisphere is pointing toward the sun. The sun is straight overhead at that point in time. And half a year from that, roughly, on the other side, you have the other equinox. Now this year, the September equinox happens on September 23rd at 9:04 Universal Time. That's 4:04 a.m. Eastern Standard Time. And so the equinox is a point in time. Now the sun is a sphere, not a point, so it actually takes 33 hours for the sun to cross the equator. So it really has a mathematical point to it. Anyway, that's the equinox for September 2011.
Welcome to What's Up in the Night Sky for September 2011. Moon will be visible starting on the 4th with the first quarter moon. You can see here in our calendar. The full moon of September, which is before the fall equinox, is not the harvest moon, but it will be full on September the 12th. The third quarter will be visible on the 20th, and the new moon, the side of the moon facing us, receiving no sunlight, will be on the 27th. As far as the planets in our solar system, the first planet you'll be able to see in our sky is in the twilight of sunset. Venus will be barely above the horizon at around 7:30 at night, just after sunset at the middle of the month. The next planet visible will be 1 hour later at 8:30 in the evening in the constellation of Virgo. Saturn will be located just to the right of the bright blue star Spica. The next thing we'll talk about is an asteroid. Asteroid Vesta, which is the fourth largest asteroid in the entire solar system, is visible in the constellation of Capricorn. Right now it has some company visiting the NASA Dawn mission, which will be visiting Vesta and recording its surface. This is the second time an American spacecraft to visit an asteroid up close and personal. Next will be Neptune, and it is visible in the southeastern sky. It is the last of the major planets furthest out from the Sun. After that, we will have, in about 3 o'clock in the morning, Mars will be rising in the sky. It'll be located in the constellation of Cancer the Crab, near the bright star cluster known as the Beehive. The one thing I want to point out is not just planets, but there are bright star clusters visible. And we'll turn to the constellation of Taurus the Bull. It is visible just before 4 o'clock in the morning. It features 2 bright star clusters. The ones at the very top are known as the Pleiades. Alternative names include the Seven Sisters, and for the Shawnee Nation of Native Americans, the 6 wives that ate onions. Below the Pleiades is the Hyades. It makes up the face of Taurus the Bull, featuring the bright supergiant star called Aldebaran. Now, Aldebaran is not actually part of the cluster, but it is a line between Earth and that star cluster. Now, in the very early morning, about 5 to 5:30 in the morning, you'll be able to see the planet closest to the Sun, Mercury. Well, it'll be visible in the twilight of dawn. It also has company. The NASA Messenger mission is getting us our first up-close look of the planet closest to the Sun. This is what's up in the night sky for September 2011. Thank you, and have a great night enjoying the skies above.